5B 1 through 3, my favorite nursery rhyme. So I want you to calculate each one of these areas by hand, and then check by using your calculator. Okay? And sometimes we'll be doing this by hand, and sometimes we'll use a calculator, and you really do need to know both ways. So find the area under the normal curve to the right of 1.25. I'm going to draw a normal curve, and it's good to get your pictures kind of appropriately spaced, just to get used to it. And remember, this inflection point right here, where we switch from concave down to concave up, that is where -1 and +1 are. And the middle, of course, is 0. And then we go out that same distance for our second SD. And then the third one comes way out here. And once you get past 3, there's really not much out there. So we can use this curve for all of the problems today. Oop, I didn't lock that one. Okay, so I want the area to the right of 1.25. So I want to know how much area is over there. Well, if I do a quick calculation in my head, I know this is 68% for the +1 and -1, which leaves 32% on either side, or sorry, 32% shared between the left side and the right side. So this piece here is 16%, which means that the equivalent piece on the other side is 16%. So the answer for this problem should be less than 16. Does everybody see that? I know that this piece is 16%, so we should be slightly less than that. To figure it out, I need to find the central area for 1.25. So I go to my table. 1.25 looks to be about 0.788, 78.8, 78.8. And that is the area, I'm running out of colors, from here to here. That's not what I want. I want how much is to the right of that area. So I have to take 100 minus 78.8, which is 21.2. What does 21.2 tell me? That's how much is to the right of that central area and to the left of the central area. So I divide that by 2, and I get 10.6 is this. Does that seem reasonable? Yes, because it's below 16. Okay. On my calculator, I'm going to clear out my draw. And then I also have to get rid of my equation. Should have done that first. So go into my y equals, clear out my equation. How do I bring back the window I created for shade norm? Zoom, and then go over to memory. And number 3 is zoom recall. And again, that only works if you have set it up this way. Okay, now I do distribution, shade norm. What is my lower bound? 1.25. And my upper bound? 5, or anything bigger than 5. 5 is, once you get beyond 5, the decimals on the calculator don't even register. So we'll just put 5, and then 0 and 1. And this picture should look exactly like the picture I just drew, and I get 10.56. Rock on. We did it right. Okay. Next problem. To the left of -0.4. So this is -0.4. Okay. I want this area. So I look up -0.4 in my table. There is no -0.4. You just do 0.4. And 0.4 has an area of 31.1. What does 31.1 describe? The central area between negative zero point 0.4 and positive zero point 0.4. So that area is 31.1. So I want the left side of that. Do just what I did before, 100 minus 31.1. Oops, that's not going to work. Okay, and what does 68.9 tell me? That tells me how much is in this chunk and that chunk. So I divide it by 2, and I get, my answer is 34.45. I can check that in my calculator, clear the draws, and then go back into my distribution. What is my lower bound? I have to go at least to -5, or anything to the left of -5, but the default on my calculator is negative 1000000, a huge number, a huge negative number. So I'm just going to leave that. I'll just push enter. And then my upper bound is going to be negative 0.4, comma 0, comma 1. And I get 34.45. Nailed it. Okay. To the left of 0.8, this is a little bit harder. So 0.8 is going to be right here. And I want this area. There are a couple different ways to look at this. So I'm going to look up 0.8 on my table. And 0.8 is 57.6. 57.6, and that is the area between 0.8 and negative 0.8. What should I do here? Subtract that from 100. 100 minus 57.6, which is going to be 42.4. What does 42.4 tell me? How much is in this chunk and that chunk? Divide that by 2. 42.4 divided by 2. I could have done that in my head. Sorry. 21.2. What does that tell you? Okay, and here, there are a couple things you can do here. 21.2 is this piece. So I could take 21.2 and add it to the green piece. We could add those together. What else could I do? Well, I know that 21.2 is also equal to that piece. I could do 100 minus 21.2. That would work. Max, how did you do it? Okay, so I figured that's how you do it because that's how you did it last time. Okay, so Dax said this is 50%, right? Okay, and then what about this piece? It's half of the 0.8 area. So plus half of 57.6. That will also work, and however you did it, 100 minus 21.2, you should get 78.8. Okay, let's double check that in our calculator. Clear the draws. And then shade norm from negative whatever, some really, really negative number, and then go up to 0.8. And we get 78.8. Right on. You guys getting the hang of this? Okay, this is key. We will be doing this so many times over the course of the whole year. The process is the same, but the statistical information is going to be it's going to change, but the process will always be the same. Okay, letter D is a little bit harder. Letter D wants to know the area between 0.4 and 1.3. So this is 0.4 and this is 1.3, and I want that area. Okay, well, I'm going to look up z equals 0.4, and that gives me an A equal to 31.1. And I'm going to look up z equals 1.3, and that gives me an area of 80.6. Oops. Now, this problem's actually kind of complicated. How do we do this? What's that? Okay, so Dax is saying, let's do this in green. Here is my 0.4 area. Right there. How much of that area actually shows up in the area I want? None of it. Okay, so that's kind of complicated. But this here, 1.3. This here is my 80.6 area. So if you notice, the red area right here, the red area is half as big as the 80.6 area minus half the area of the 31.1 area. Do you see that? So here's what I'm going to do. Oops. We'll take this. So that area, okay, and then I want to subtract off, I want to cut that in half. Is this equal to what I want? No, it's a little bit too big. How much too big is it? It's this much too big. So if I could figure out what that chunk is and subtract it off, now I have the area I'm looking for. So I have to take the 80.6 and cut it in half, and that will limit me to this side. So that's 40.3. But 40.3 is too big. Well, how much too big is that? It's too big by this piece. And that piece is half of the 31.1 area. So I need to subtract off half of 31.1, which is 15.5, whatever. We're just going to do it the easy way. 40.3 minus 0.5 times 31.1. And that gives me 24.75. Now that's hard to do, right? That's how they used to do it. After this assignment, we're just going to use our calculator because it makes it so much easier. But it is valuable for you to see where that number comes from. So, clear my draws. And this is really where the calculator shines. When your left and your right endpoint are different values, it makes it really nice. From 0.4 to 1.3, comma 0, comma 1. And I end up with, oh, I pushed enter too many times. But it said, let me just hit enter again. It'll regraph that for me. 24.77. Which is what we got. It's really close. Okay? Does everybody understand that one? You certainly understand the calculator version, correct? Cambry, did you get your calculator to do this? I'm not sure if it will. But you can always do it this way. Yeah. Okay, the area between negative 0.3 and 0.9. Negative 0.3 and 0.9. Is this one going to be as hard? Why not? It has different endpoints. They're on opposite sides of 0, and that makes things a lot easier. All right, so the area... Nope, that's not what I wanted. When z equals negative 0.3, the area is... Somebody look that up. 0.3. 23.6. And then when z equals 0.9, the area is 63.2. So if I want this area, what should I do? Well, it's half of the 0.3 area and half of the 0.9 area. That's really easy. 23.6 divided by 2 plus 63.2 divided by 2. 43.4. Let's double check with the calculator. And lower bound is negative 0.3 and upper bound is 0.9, 0 and 1. 43.3. It disappeared again, but it said 43.3, which is what we got this way. Now, are we going to worry about that 0.1 difference? No, because none of these numbers are perfect anyway. So, and you'll see the book actually rounds lots of things, lots and lots of things. Okay, and the last one, outside of negative 1.5 and 1.5. So here's negative 1.5, and here's positive 1.5. What does outside mean? To the left and to the right. Okay. So I look up z equals 1.5, and I get the area is 86.6. Okay. How do I find the outside area? Just do 100 minus 86.6. 13.4. How do we check this on the calculator? You'd actually have to do either two graphs, two shade norms, or you could do one and times it by 2. So you could do from negative 5 to negative 1.5 and hit enter and times that by 2, or you could add it to 1.5 to 5. So in this case, the table is actually faster. If you're finding an outside area, this table is actually faster. And well, I won't go there. All right. Number 2, fill in the blanks. The area between plus or minus what under the normal curve equals 68. So now we're going backwards. If we know that our central area, so whatever our central area is, if that is equal to 68, then how far out do I have to go to capture that? 1 SD. That one's easy. Okay, what if that central area for the next one is 75? What do I have to do? You have to kind of reverse engineer it. Instead of using a z value to look up an area, now we look at an area to find a z value. So I go to our table, area 75. What did you get? And I would say it's probably 1.15. right? Between 1.14 and 1.16. But if you put 1.14 or 1.16, it's not going to matter. That much of a difference is not important. Okay. All right. The normal curve is sketched below. Find the value of z. So if my area is equal to, my central area is equal to 90%, what do I do? Go to the table, go to 90%, and what would you say? Probably 1.65. Okay, that's easy. Now, this next one is tricky, and we're going to be doing this a lot. And it's sad that there's only one problem with this on it, but that's life. So, over here I have some z value. I don't know where it is, but I know that the area of everything to the left, so all of this stuff, is 90%. The question is, where is the z? How do you figure that out? Can I look up 90% in the table? No. Why not? The table only tells you central area. Did anybody figure this out? Oh, well, hold on a second. Let me wrap my head around this. So you did, oh, okay, that'll work. So Dax's method, and this isn't, anyway, this is how he likes to do it. This is 50%, right? Which means that this is 40%, which means that this negative z to z is 80%, and then you can look 80% up in the table. Okay? Dax just likes to divide things by 2, but whatever. Okay, and then, all right, what were you saying? Oh, did anybody else do it a different way? Okay, this way hopefully will make more sense to you guys. How much area is over here? 10%. So if I go over here to negative z, how much area is over here? 10%. Which means that the middle is 80%, and now I have a central area. I can go to the table, 80%, what would you say? 1.2, I would say 1.28, right? 1.29 would be 80.3, so 1.28. That is how far you have to go to the right and to the left to capture 80% of the people. And we will do this a lot. How much area is to the right? Take that area, stick it on the left, calculate a central area, and then look up your z-score in the table.